Hello, I'm Papia. In this problem, we have this equation. We have to compute d2y dx2 implicitly. So we have to compute the second order derivative. Now, in order to do that, we have to first compute the first order derivative and then the second order. Okay? So this is implicit differentiation. So the first step is apply d dx to all the terms, to the left side and the right side of the equation. So let's do that. So we'll have d dx of 7xy plus d dx of sine x, that's equal to d dx of 2. Okay, so let's evaluate each derivative separately. Now, this is implicit differentiation. Notice that in the first term, we have a product of x and y. They're both variables, and we are taking the derivative with respect to x. So you have to be extra careful. Okay. So for the first term, of course, we're going to use product rule because it's a product of two functions. X is a function, y is another function. So first, take out the constant 7 and then apply product rule. Okay, so keep x as it is, take the derivative d dx of the second function, that's y, plus keep y as it is and take the derivative of x, the first function. That's product rule. For the second term, we just have one function, sine of x, and there's just the variable x. Okay, notice that you are differentiating sine of x with respect to x. So we just use our derivative rule. Derivative of sine of x is cosine of x, and that's it. Right hand side, you are computing derivative of a constant, which is 0. Okay, so let's figure out the derivatives here. So we have 7 times, keep x fixed. Okay, what is d dx of y? Now here you have to be very careful, right? We have x is different than y. They're two different variables. And this is where the implicit differentiation comes into play. Well, d dx of y is just dy dx. Okay, so you cannot ignore the fact that we have another different variable y. So keep it as dy dx. Plus y times, what is d dx of x? Now here it's okay, see the same variables? You are differentiating x with respect to x. So it's just going to be times 1. And then you still have plus cosine of x is equal to 0. Let's simplify here. We have 7x dy dx because I'm multiplying 7 throughout, and then 7 times y, so plus 7y plus cosine of x is equal to 0. So from this equation, I am going to find out what is dy dx equals to, and then we will have the first order derivative. Okay, so let's keep the term that has dy dx on the left side of the equation, which is the first term, and notice that the next two terms don't have any dy dx, so move them to the right side. And so you will have negative of 7y and negative cosine x. And then what is dy dx? Just divide by 7x. So dy dx is equal to negative 7y negative cosine of x divided by 7x. All right, so we have the expression for dy dx. Now we have to compute, remember we have to compute the second order derivative, d2y dx2. Okay, so let's do that here. So what is d2y dx2? By definition, that is the derivative of the first order derivative. So d dx of dy dx. Right? So let's plug in the expression for dy dx. So we have to compute the derivative of, here is dy dx, 7x in the denominator, numerator is negative 7y, negative cosine of x. All right. Of course, you see, we have to apply quotient rule here. So let's do that. Okay, so denominator gets squared. Okay, in the numerator, you take 7x and write it as it is, and then you have to take the derivative of the numerator. So d dx of the entire numerator, negative 7y, negative cosine of x. Then you subtract. For the second term, you keep the numerator as it is. So negative 7y, negative cosine of x, times you take the derivative d dx of the denominator, 7x. Okay. So let's evaluate all these derivatives next. Okay, denominator remains as it is. You don't have to do anything with it. In the numerator, we have 7x times. Okay, now be careful again. See, the first term has y, and you are differentiating with respect to x. So they're different variables. So you will have an extra term of dy dx again. So let's do it carefully. First, you pull out negative 7, and then d dx of y is just dy dx. All right. Next term is negative cosine of x, same variables, so it's fine. So minus, what is the derivative of cosine of x? Negative sine of x. So you get another negative sine x. So be careful, there's a negative times negative, so it will become positive. Continue. Next, we have negative of this expression, negative 7y, negative cosine of x, times d dx of 7x. Again, notice that same variables, x and x, so we will not have any extra term. The derivative is just 7. So we have all the derivatives been evaluated, but notice that we still have a dy dx sitting here, and we have to compute d2y dx2 in terms of only x and y. So you cannot leave your answer in this form. You have to plug in whatever expression we have from dy dx in here, and then you have to simplify. Okay, so first let's simplify a little bit here. So multiply 7x through, so you get negative 7 times 7, negative 49 x dy dx. Then we have a negative times negative, that's a positive sine x times 7x. So plus 7x sine x. Here, see, you can distribute this negative through, and since both terms are negative, they will all become positive, times 7. So you get positive 7 times 7y, that's 49y, then positive 7 cosine of x. And then the whole thing is divided by 7x squared. Okay, so let's continue. Let's move up here. So we will have negative 49x times dy dx. Well, now we have to plug in the expression for dy dx. Recall that dy dx is negative 7y minus cosine of x divided by 7x. So to plug that in, and then the remaining three terms will remain as it is. So we will have plus 7x sine x plus 49y plus 7 cosine of x, and everything divided by 7x squared. Okay. Note that for the first term, we can definitely cancel out the x and we can divide 49 by 7. So we'll get a 7 here. Okay. So, and the negative was in the front, so negative distributes, both terms will be positive. So we will have positive 7 times 7y, so 49y, then plus 7 cosine of x plus 7x sine x plus another 49y and another 7 cosine of x. Whole thing divided by 7x squared. So we're almost there. Now we can combine the like terms together and then simplify. All right, so let's see. We have 49y plus 49y. Can add them together. So 2 times 49. So that's 98y. Then we have a 7 cosine of x, another 7 cosine of x. You can add them together. So that's plus 14 cosine of x. And we have a 7x sine x. And divide the whole thing by 7x squared. So this is our answer basically. This is the second order derivative. If you want, you can simplify maybe one more step, because see, denominator you have a 49x squared, so you can cancel out at least one of the 7's because you have a factor of 7 in the numerator. So if you want, let's do that. So let's see, denominator we have 49x squared, so let's keep one of the 7's, 7x squared, and then cross out 1 7 from each term. Okay, so we will have, this is a 14y plus 2 cosine of x plus x sine x. And therefore, this is the final expression for the second order derivative. That completes the problem. Thank you.